This video shows an example of how to graph a secant function that has a vertical shift and a phase shift and a reflection. That's what's going on with this one. If we consider the generic version of the secant graph, where we have or of the cosine graph, secant is related to cosine. So the first thing we're going to do is graph this. For reference, y equals to -1 minus the cosine of x minus pi over 2. The secant graph is related to the cosine graph. So if we're able to graph this cosine graph, then we can do the secant graph. Now secant is defined as secant of x is defined to be 1 over the cosine of x. So whenever you have a rational function like the secant function, where it's possible to be dividing by 0, that's where vertical asymptotes come from. So the vertical asymptotes are going to come from whenever the cosine function equals to 0. We're graphing cosine of x minus pi over 2. So the vertical asymptotes are going to appear differently than they would if we were just graphing secant x, because cosine x is 0. If you think of the unit circle, cosine x is 0 at pi over 2 and 3 pi over 2. So that would be where the asymptotes naturally occur for cosine, or negative pi over 2, pi over 2 and 3 pi over 2 are where the asymptotes would occur for cosine, but it's going to be shifted because of this phase shift. So I just want you to keep in mind that we will have vertical asymptotes whenever we graph secant x or cosecant x. So we begin by graphing this. Here is the generic function y is equal to c plus a times the cosine of b times x minus d. And so let's look and see what's going on with this graph. We have a vertical shift down 1. So this is down 1. I'm going to do vertical shifts at the very end. Our amplitude A is equal to -1. Now the cosine graph will go between 1 and -1, but this negative right here, this indicates a reflection. So we'll take care of that. B is equal to 1 in this case, so the period of 2 pi will not be affected. It's still going to be 2 pi. So the period is equal to 2 pi over b, but b is 1 in our case, so it's 2 pi. Then we find the spacing between our main points by taking 2 pi, you divide by 4. So if we take 2 pi divided by 4, that gives us pi over 2, and this is going to tell us the spacing between our x values. And then if we want to graph this cosine graph, we set up this interval and solve it. Let's see, 0 is less than or equal to x minus pi over 2 is less than or equal to 2 pi. And this will give us the interval over which we need to mark our x values. So we solve this for x. I'm simply going to add pi over 2 to all 3 places. Over here, plus pi over 2 gives me pi over 2 is less than or equal to x is less than or equal to 2 pi plus pi over 2 gives me 5 pi over 2. So this tells me what to mark on my graph. This is the period over which we'll be graphing. And then this tells me the spacing I need to put my point. So we start here at pi over 2. And then we're going to go plus pi over 2 will land us at the next place of pi. Plus pi over 2 lands us at 3 pi over 2. Plus pi over 2 lands us at 2 pi. Plus pi over 2 lands us at 5 pi over 2. So those are our 5 x values we're going to be concentrating on, and that's our spacing between pi over 2. So if we think of the cosine graph, and it's going to be between 1 and -1. So I'm going to put my 1 on here. I'm going to put my -1 on here. Cosine, and this is where our first mark, cosine starts up here. And I'm going to erase this in a minute. I'll tell you why. But our cosine graph starts up here. And then it goes to 0. And then it goes to -1. And then it goes to 0. And then it goes back up to 1. However, in this particular one we're graphing, there was a reflection. which means it reflects across the x-axis. So when we would normally be up here at 1, instead we're down here at -1. That's where this one's going to be. I'm going to make this a little more symmetric, like it should be. This is my -1. Then it's going to, 0 is still going to be at 0. This minimum value will turn up here at 1, which makes it a maximum. And 0 stays at 0. And this 5 pi over 2 will be down here at -1. All of these changes were because of the reflection that we saw in this graph. So then if we were going to, I'm going to dash this. We're going to dash this graph, because this is not our real graph. This is dashed. So if we did our cosine graph, it would look like this. Okay, and so this is a decent looking cosine graph for negative cosine x minus pi over 2. That's all we've done so far. The last thing is this vertical shift of -1, and I'm going to simply do that. This is a little bit of a cheap way to do it, but I'm just going to adjust my scale. -1 minus 1 gives me -2. That means that this value is -1. That means that at 1 it turns into 0, and this is my new x-axis right here. And then above that would be 1. So this gives me the correct values of where this needs to land. Now this is the graph of cosine graph. It's not the graph of secant. Secant has asymptotes in it. The asymptotes are going to occur at where it's crossing 0. So these are going to occur at pi, and I'm going to show you how to confirm this. You don't have to guess about any of this. And 2 pi, and multiples of pi for this particular graph. And so our secant graph, this is not going to be dashed. These are vertical asymptotes. X is equal to pi. X is equal to 2 pi. The next one would be at 3 pi right here. This is where the next asymptote would be on this graph. X is 3 pi, and so on. Okay, so this is what the actual secant graph looks like. It's right here, and then it's kind of the opposite of what this little, the minimum of the cosine, and then it goes up like this. It's going to go down like this, and this is the graph of -1 minus the secant of x minus pi over 2. This, we kind of thought about it and figured out where things go. You can always confirm that your points are in the right places, that your asymptotes are in the right places by point plotting. I'm going to put my x values down here, and the ones I chose to put in were pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, to confirm that I have graphed this correctly. And so -1 minus the secant of x minus pi over 2 is what I wanted to graph. So if I think about, I'm going to put in pi over 2 for x. So pi over 2 minus pi over 2 is 0. So we're looking at the secant of 0. So this is where 0 is. Secant, this point is 1, 0. The cosine is 1. Secant is 1 over 1. So at pi over 2, at the secant is 0. This value right here is 1. -1 minus 1 is -2. Let's see, what did we graph at pi over 2? We're down here at -2. That is correct. If we were to put in pi minus pi over 2 is pi over 2. The secant of pi over 2 is what we're interested in. Here on our unit circle is pi over 2. This is 0, 1. 1 over the cosine is 1 divided by 0, which is undefined, which is telling us that is where our vertical asymptote should be. If you continue this process, you're going to find that at 3 pi over 2, you get the value 0, you get undefined, and then at 5 pi over 2, you land at -2. And so this is a good graph, because at 3 pi over 2, we're up here. This is our new x-axis, which is the value of 0. So it's going to confirm, it's going to be in sync if you've graphed this correctly.